So now that we're confident that the machine is level, we can start with the alignment. The first thing that I want to do is remove the turret, and this is not a necessary step. If you're confident of the condition of the machine, you do not have to pull the turret. The reason that I want to pull the turret is that I did some checking before we started this process, and I'm confident that the turret is out of adjustment radially, meaning the curved coupling needs to be adjusted. And the manual does not seem to indicate that there are tapered pins in the curved coupling, but I don't know that for sure. So I want to take the curved coupling apart. Number one, to inspect it, make sure that it's seating good, make sure that the dust seal around the outside is in good condition, and to investigate whether or not this machine has tapered pins. If it has tapered pins, they're probably bent, because I know that the alignment is bad right now. So it's really not that hard to pull the turret. All we're going to do is take this lock nut loose right here. It's a split style nut, so these two screws here basically pinch the threads. We'll take those loose and pop that nut loose. This row of screws here is basically the flange. So the flange attaches to the turret, and the flange contains the splines that go on the spline shaft that goes through the turret. So we don't want to take these screws out. There's no reason to change the relationship of the turret to the splines. Now on this machine, it has hydraulic clamping of the turret, so basically the turret pops out, indexes, and then pops back in. So this lock nut does not have to be that tight, but because the hydraulics are pulling the turret back, that's going to put some force on this nut. Now I could take the back cover off the turret and find the solenoid valve that controls the actuation of the locking piston. But what I'm going to do on this machine, when you hit emergency stop, the hydraulics are also stopped. So I just e-stop the machine. I'm going to let it sit for a little bit, let the pressure hopefully diminish, and then we'll get to it. And it's actually been in e-stop for about 20 minutes now, so I think that's probably sufficient. And we're going to give this a try. These bolts out here are into the curved coupling, like I said, and then there are two plugs here for some M12 holes. I don't know exactly the purpose of those, but I would assume that those are for jacking screws to push the curved coupling out if you ever needed to replace it. So we'll take a look. I don't see any holes for taper pins, but that doesn't mean that they're not there. Usually they are put in from the back side. That's why the first time that you crash the machine, you're going to have to pull the turret. So I'm going to grab some tools and get to it. Now this is a nut that would use a hook spanner, and I have the right hook spanner for this nut, but it's actually underneath the face of the turret, so it's recessed, and I don't have a crowfoot type spanner wrench or a spanner socket, which I'm sure is what they used. So we're gonna have to do the old maintenance man trick and hit it with a punch. Like I said, shouldn't be that tight. Also, little tip for any rookies, I ran the machine all the way down in X to its maximum travel. You know, try to make things easier for yourself. You don't want to be leaning all the way into the machine, working on the turret, and you for sure don't want to obscure the top of the turret, because this turret is small, but it probably weighs, I don't know, 80 to 100 pounds, and I don't want to lift it, you know, for any reason by hand. So we're going to put an eye bolt in the top of the turret and get the gantry crane over here and see if we can slide this bad boy off. And just so happens that I have the right size eye bolt. It's an M10. Go ahead and get that on there now. Okay, I'm gonna put the lock nut back on loosely, and then we're just gonna see if we can pop that turret loose from the spline. I don't know if you can see it on camera, but the spline is right here. And by the way, this tool that I'm using right here is called a die bar. This is made by Mayhew. If you don't have one, you need one. And preferably you need two. They're really handy to use in pairs. And I also have a longer one. Handiest tool that you can imagine for work like this. Alright, we've got it chained up. Let's see if we can get the rest of the way off there. Coming off's the easy part. Getting it back on that spline is where you can become frustrated. Okay, that's it. That's what we're left with. The backside of the curved coupling is here. This ring right here is where we are going to have the dust seal will sit, and you can see it's had some chips built up on the top of it, and there's a little rust I need to clean up before we can put the thing back together. But the bearing surfaces of the curved coupling look fantastic. Yeah, this machine I suspect has very low hours on it. It's a 97, but I just don't think that they ever used it. It sat more than anything, which can be just as bad as you know, other kinds of neglect or abuse. But I really think we're going to get lucky here. So I'm going to take the wire brush or some sandpaper maybe and clean up the top of this surface. And next, now that I look at it, the seal actually rides on the outside of the curved coupling. So this surface is actually just a kind of a debris shield. And yeah, I'm still going to clean it up. And now that I look at it, I don't see any taper pins in the curved coupling. There is a tapped hole here and here, which again I'm assuming is for jacking screws to pull the coupling if you need to. Yeah, looks really good. There's the bearing for the spline shaft feels nice and tight. Yeah, I think we're going to be just fine. That's something that you need to watch out for, especially if people aren't careful to balance their turret. Sometimes these bearings on these shafts can take a real beating. and then obviously if you crash it, all bets are off. Okay, we got it cleaned up. The curvic is cleaned. One thing that I should say you need to pay attention to, right here, this is the port for the coolant, for a through turret coolant. Different makers have different ideas on how to do that. Mazak uses a spring-loaded plunger with an O-ring on the face, or a rubber seal on the face. This one apparently is just a rubber grommet, and I guess the turret must just crush it a little bit. I don't know, I've never run the machine, so I don't know if it leaks or not. But it looks like it's in good condition, so I'm going to try and put it back together and hope for the best. Okay, this is the back side of the turret, and there are tapered pins, but Ghosts of Mechanics Past looks like they've been removed. This is a hole here, and there was another hole here. Those would have had taper pins in them originally. There's kind of debate on whether you should put the pins back in. My personal feeling is that once the machine's been crashed once, you might as well take them out. They're not doing anything anyway. The chances that you could put those new tapered pins back in those holes, line the curvic back up to the original spec, and have it actually be right is pretty minimal in my opinion. Now, that being said, I have run into some exceptions to that rule. Recently worked on a large Morisinki lathe. It had, I believe, 6 tapered pins on the fixed side of the turret, and 5 taper pins on the rotating side of the curvic coupling. And our only conclusion was that they must have been using the taper pins to actually help retain the curvic coupling, resist the rotative forces. I don't think that's a good idea, but I guess Morisinki decided that that's what they wanted to do. So in that case, we had to ream those holes and install new taper pins. I guess the system on that Morisinki was that there were 5 tapered pins, or tapered holes with pins installed, and then a 6th master hole that was reamed and aligned, but no pin was installed. So I guess their thinking was that if you crash the machine, you pull the 5 pins, toss them out, rotate the coupling back, and align it using the master hole, and then I guess re-ream the other holes and install new taper pins. I'm not really sure what their thinking was, but that's what we did, and it worked fine. But for small lathes like this one, I don't see any reason to have the taper pins in there. The screws can handle the rotative force. It's not a problem. So we're going to go ahead and put this thing back on. I really didn't find anything out of the ordinary. Yeah, there's some crud in here, but I don't think it'll be a problem. This seal right here, rubber dust seal, it's in pretty good shape. I don't think we're going to have to worry about it. So I'll put it back on, and that is not easy. These splines can really fight you. And you probably can't see it on the camera, but one of the teeth on the spline is actually relieved. And inside this flange is a pin. And if you try to put the flange on the wrong teeth, basically out of time, you will not be successful. And that's a good thing. We want it to be idiot proof. If you were to happen to take all these screws loose, you would lose the timing between the spline shaft and the coupling. Yeah, you'd probably have to go through some procedures in order to get that back. There's no reason to do that. Different manufacturers have different ideas on how to do that. Mazak usually uses a tapered sleeve, so that they can basically have the spline shaft where they want it and the curvic coupling where they want it. tighten up that tapered sleeve, everything's happy. Morisinki, they use a flange like this with screws in it. The 10 station turrets are a no-brainer. The 12 station turrets can be a pain in the butt because, well, we're getting a little far afield. But yeah, no reason to take that apart. Just take the nut off. Not a big deal. So we'll see what happens here. Okay, we're started on the spline. I'm just going to start this nut. It's a dead blow hammer. So again, I don't have the right wrench to tighten this nut. So again, we'll use the Maintenance Man secret weapon right here. And you don't need to kill it. There's no reason for that thing to be super tight. I don't know if you can see it on the camera, but you can see how the turret can rock back and forth a little bit. That's because we don't have hydraulic pressure. As soon as the hydraulics kick in, it's going to suck right back in and should be good and tight. There's a trap built into this machine, and I have not actually run into this before, although I'm sure it's very common. This is a drawing of the end view of the machine. So that's the base. These are the ways, and you can see the sheet metal over here. This is not a true slant bed machine. So on a true slant bed machine, the ways are machined on a slant, and the mounting pad for the headstock is also machined on the slant. So it's basically, a slant bed machine is basically just a flatbed lathe set up on an angle. And when you do an alignment on a slant bed machine, you basically just make a test cut, check the alignment of the headstock. If there's taper, you rotate the headstock, which is mounted in the same plane as the x-axis, and then to set the turret alignment, you can just sweep in one of your boring bar holders. The center line of the turret is the same as the center line of the headstock, and it's pretty simple. This machine has a curve ball that makes it a little more complicated. Because it's not a true slant bed machine, but the x-axis is still on an incline. So basically there's a ramp inside the machine, or a wedge shape. the x-axis is inclined, but the headstock mounting surface is horizontal. So the adjustment for the headstock is side to side horizontal and rotating in the horizontal plane, but that's not the same plane as the x-axis. So that makes it a little more tricky. What we're going to do is set the rotational alignment of the turret, the curvet coupling, by using the stick tool holders. So we'll actually sweep along the stick tool holder and make sure that those are parallel to X. We'll also have to check the face of the turret, make sure it's parallel to X. So at that point, the turret will be aligned to the X-axis, and that will be ready to go. Now the headstock is going to be very tricky because we have to do two things with the headstock. We need to align the center line of the spindle to the Z-axis. That means to remove any taper that the machine is cutting. And we can do that by loosening the screws that hold down the headstock and using the jack screws to rotate the headstock. But we also have to be very careful about where the headstock is on this horizontal plane, because we need the center line of the spindle to intersect with the center line of the turret, which is on an incline. So I'm not exactly sure how we're going to do that just yet. Probably what I'm going to do is align the turret to the x-axis so that it's ready to go, and then sweep in one of the boring bar holders and just see where we're at. And we're probably not going to be very far off. And if we're reasonably close, then I'll take a test cut with the headstock and see if we're turning a taper. And then we're probably just going to have to kind of iterate until we can get to this magical point where the headstock is both aligned to the z-axis and the spindle center line is aligned to the turret center line in this incline. So that's probably going to be a tricky process, and there may be some back and forth there. On a true slant bed machine where the headstock's mounted on the same angle as the x-axis, it's much easier. You basically don't have to worry about the matching up the height of these center lines. It's all built in. Yeah, I'm not exactly sure why they would do it this way, and there's no manufacturing advantage as far as I can tell either, because the turret sits on shims that can be ground, and the headstock sits on shims that can be ground. So both of those center lines are adjustable in their own plane, but in order to make the planes intersect, it's going to be a bit tricky. And I wanted to show you in the manual. Don't know if you can read this, but there's actually this nice little warning note right here, which says the headstock alignment is an operation that directly influences the machine precision and should be made by a skilled professional. In case the customer does not have the proper conditions, this service must be made by an authorized technical assistant. So, be warned. Like I said, this information is worth exactly what you're paying for it. But somebody built it, that means we can fix it. Not going to be that bad. It's just going to be an extra step that you normally would not encounter on a Mazak or a Morisiki, a true slant bed lathe. And by the way, if anybody else knows of another machine that's built this way, please let me know, because I'm curious. I haven't seen all kinds of machines. I haven't seen even a small fraction of the machines that are out there. So I'm really curious to see if any other manufacturers felt like this was a good way to go about it. It certainly seems like a poor way to design the machine to me, but what do I know? I don't know how well you'll be able to see this, but this is the first check that we're going to make as far as the actual alignment of the machine. So right now what I'm doing is checking to make sure that the face of the turret is parallel to the x-axis. Yeah, I'm just using the outside face of the turret and an indicator. I don't know if you can see the dial or not, but that's about 2.5 thousandths total reading on the indicator over a distance of maybe 10 inches. So that's really not that bad, but we're going to see if we can make it maybe a little bit better. Okay, we're going to have to go handheld here for a second so I can explain how to adjust the turret. Basically, what we want to do is take the turret and rotate it this way, and that's not that hard to do. You can see at the base of the turret there's 3 cap screws, and then you'll see there's 2 holes in between the cap screws. Those are tapered pins. Those pins are probably gonna have to come out, and once they're out we will leave them out. Now the bottom side is easy. The top side is not easy. See this weight cover right here? We're gonna have to take that loose and push it back as far as possible, and I imagine we'll find 2 or 3 more screws that hold the turret down. So might as well get into it. Alright, I've got the screws loose and the cover off. I think what I'm going to do is go ahead and remove one of the taper pins. I'm going to leave the other one there because this turret doesn't have a shoulder or anything that seems to locate it. So I'm going to go ahead and leave one of the taper pins there, and I'll just pop the other one out. Yeah. So if you want to pull taper pins, you need a tool like this, and it's a slide hammer. This particular one is an old pilot bearing puller made by OTC. It's pretty small. I think it's only about 1.5 pounds. And then just got this end on it here, and this end is machined to accept the head of a socket head cap screw. You can buy these ends from Reed or McMaster-Carr. They're commercially made. I just made this little adapter nut to put it onto this this particular slide hammer. So the taper pins are threaded. This one's I believe an M5. Oh, let's see what happens. There we go. Yeah, nothing to it. Okay, I got the x-axis dialed in about as close as I can get it. Everything's bolted back up. We only have one taper pin now, but there's no reason that will cause a problem. Let's take a look here real quick. That's as close to no movement as I can get it. The needle does shake a little bit at the far end. I think there's some corrosion or pitting in the face of the turret. Not a big deal. So we're going to move on to the next step, which is to set the alignment of the curved coupling. Alright, I have 2 stick tool holders mounted onto the turret. They're on opposite sides of the turret. The idea here is to jog the turret, or the x-axis, and check for run out on the top locating surface of those 2 holders. And then I'm using 2 holders. I'm going to try to average the 2 because there's always going to be some variation or some error. Okay, that's not very good. The length of that tool holder block is, I'd say, 4 to 5 inches, and we have about 8 thousandths of indicator runout. So we need to loosen the bolts on the curved coupling and smack this thing back into some kind of location that will be a little closer than that. Okay, so the indicator is going positive as the X goes positive. So that means that the tool is actually low. So we need to rotate the turret this way. Now all the screws are loose, but we still have the hydraulic pressure pulling the turret back. So it's not going to be an easy. You know, it's not just going to move from us, giving it a mean stare. We're gonna have to smack it. Okay, so we got to get this turret a whack. I don't know if there's a good place to hit a turret, but I guess I'll try to stay away from the locating faces. I'm gonna hit it on the tool holder, and we'll see what happens. It should move pretty easily. Like I said, all that's holding it is the hydraulic pressure, and yeah, that's not that much on this machine. Now you have to go more than you would expect. This machine, the turret was out of alignment by like 8 thousandths, so I went about 16, and I'm probably going to have to go more because the center of rotation is far away from the reference surface that you're measuring. So it's not immediately intuitive how far you need to move the turret in order to get it lined up. So we'll give this a try. Yeah, so that's pretty good. It's actually pretty close to zero. That the tool holder must not be exactly flat. The indicator kind of rises in the middle and settles on the ends. So might have gotten lucky there. I'm going to flip the turret around 180 degrees, check the other side, see if they agree. Okay, did one more adjustment and the tool holders seem to be pretty consistent. Let's say we're within a 1/2 thousandth, and that's good enough. I'm going to let it go. especially between two tool holders. I think that's good enough. So, we'll tighten these coupling bolts down. So my advice would be to tighten these just as tight as you dare. They're only M8 screws. You know, you're gonna have to be careful. Some machines have, you know, obviously larger machines will have larger screws, but the tighter you get these, the less the chance that the curvic will slip under normal use. You know, which means a heavy cut or, you know, some kind of extreme operation that you're doing. But you don't want to get them too tight to where you break them or strip them out. That's a bad deal. Also, you know, the machine is inevitably going to be crashed. It happens to everyone. It happens to every machine. You know, if things can slip, most of the time they don't break. Just the slipping of that curvic coupling dissipates a ton of kinetic energy that otherwise would be used to break something. So, you know, in the event of a crash, we want things to move. We don't want it to be perfectly rigid. There's a reason that they put all these joints in these machines. Real quick, I just wanted to give a little tip. When you're setting up your indicator to take these kind of measurements, it's real tempting to mount the indicator to the chuck, but that's a bad idea. You know, even if it's a big heavy chuck, they tend to move. So what I do is you know, find something that's fixed in the machine where you can attach your indicator mag base. In this case, I just went right onto this bearing retainer up against the wall of the machine. Nice rigid place to mount your indicator. So we've got our turret essentially all lined up. There's a little more to it. We'll get to that in the next part.